Hi everyone, welcome to another maths video by Maths with Sarah. So I asked my Instagram followers last night which one out of surds and quadratic inequalities they found the hardest, and quadratic inequalities was by far the one that people voted for. So today's video involves quadratic inequalities. So this question, as you can probably guess from the fact that it involves quadratic inequalities, it is the final question on a non-calculator paper. So definitely looking at grade 9 material, it is a real tough question. But I'm going to talk you through it. So as with all these videos, I would ask you to pause the video now, have a think at least about what method you would use. Even if you can't do the whole question. If you can tackle the whole question, then fantastic. But if not, and if you get stuck, don't worry, just pop back in a few seconds after you've had a little think and I'll run through it. Okay, so this question involves a rectangle and a right angle triangle. And we've been told that the area of the rectangle is greater than the area of the triangle. So, and it wants to find the set of possible numbers for x. So the area of the rectangle is going to be equal to these two times each other. So that's going to be 3x minus 2 times by x minus 1. And we know that that is greater than the area of the triangle. So the area of the triangle is going to be 2x times x. So that would be 2x squared, divided by 2 because it's a triangle. So if we cancel these out, we just get the area as being x squared. So the way that I always do inequalities, just to make it easier for myself, is to always remove the inequality and just set it as an equal sign for now. So the exception to this is if we have to divide by -1, we have to consider the inequality sign and just have to flip the direction. But normally, in 99% of the time, you're absolutely fine by just setting it to an equal sign and popping the inequality sign back in at the end. So that's the way we're going to do this today. Okay, so if we're looking at this question, as with all quadratic, hopefully you can see that we're going to be doing quite a bit of quadratics in this question. It's easiest if we end up with 0 on one side. So if we multiply out the brackets, we're going to end up with 3x squared minus 2x minus 3x plus 2. And then if we minus this x squared from both sides, we're going to have this long thing equal to 0. So now if we simplify this by collecting all the like terms together, we're going to end up with 2x squared minus 5x plus 2. And that again is all equal to 0. So now again, as with many of these questions, there are multiple different ways of doing it. I'm going to be doing it the method where you pop this into brackets and then solve it from there, because you can put it in brackets and it's a little bit quicker and easier than using the quadratic formula. But if you prefer to use the quadratic formula, then that's absolutely fine and you will get exactly the same answer. So if we put this into brackets, I'm going to assume that you're all familiar with doing this, and you're going to end up with 2x in one bracket, x in the other, and then we want to find two numbers that are going to times to make 2 and subtract to make, or to add to make -5. And you can do this by trial and error. There are multiple different ways of doing it, but these are the two numbers that I came up with. And as with all of these, I'm a big believer in checking your answer as many stages as possible. So for me now, I would immediately be multiplying this out. So you get 2x squared minus x minus 4x, that's going to be minus 5x in total. And then -1 times -2 will give you +2. So brilliant. This answer equals what we started with. So we can at least be sure that we've got that section right. Okay, so now we've got our equation in brackets. So the next step is going to be to solve this. So because we've set each bracket equal to 0, we can now say that if we set this bracket equal to 0, we're going to get x, 2x minus 1 equals 0. Because remember, if this was equal to 0, then that would mean doesn't matter what this bracket is, then the whole thing would equal 0, and equally the other way around, because you're timesing by 0, you're always going to get the overall answer of 0. Now if we solve this for x, we'll add 1 to both sides, and then divide by 2, we'll end up with x equals a half. And if we do the same with this bracket, if we have x minus 2 equals 0, then we're going to end up with x equals 2. So we've got two answers. How do we work out which one is correct in this case? Now, this is where the quadratic inequalities comes in, and it can get a little bit tricky, as if the rest of the question was easy. Okay, so with this, I'll just draw the easiest way to show you what I'm doing is by drawing a graph. So we've got this graph, we've got this being the x-axis and this being the y-axis. Now we know that when y equals 0, i.e. along the x-axis, x equals a half or equals 2. So if we're going to draw a quadratic curve on here, we can draw it looking something like this. We know that it's going to cross the x-axis at a half and at 2. Now, the information that we've been given is that this equation here, so either of these equations here, actually I'm just going to write it out instead, we know that 2x minus 1 x minus 2, doesn't matter whether you use this equation or this one because they obviously both equal the same, equals 0. If we pop the inequality back in, we can pop it in here. So that means that we know that this is greater than 0. And that means the area under the curve that is greater than 0. So we're only interested in the values where y is greater than 0. And that means that we've got this set of values here and this set of values here. Because it can only be greater than 0 at the values of x that are greater than 2 or x is less than a half. So if we tested any of these values, if we put 1 we substituted that in here, we would get 2 times, if we're substituting in 1, we get 2 times 1, so that would be 2 times by 1 again, so this would give you a value of 1 for the area of this triangle. If we then did the same for this one and we substituted in x equals 1 just to test whether or not this theory is correct, we get a value of 0 for this, so obviously not correct because we're going to get 0, and as you're all aware, 0 is not greater than 1. If you at all, you can have an area of a rectangle of 0. But if we test it with, say, 3, because we've said that we know that x is greater than 2 or less than a half. Now, because we're looking at a length, it's highly unlikely that x is less than a half makes much sense, does it? If we're going to have to pick one of these, it's far more likely that the length has to be greater than 2 than less than a half, because that's looking into minus numbers. Now, x cannot be negative. We know that the value of x cannot be negative, it can't be 0. So basically, this pretty much avoids nearly every single value. So this one seems far more plausible. And this is, in fact, the correct answer. So the correct answer is x is greater than 2. But just to check that that is correct, let's try substituting in, say, for example, x equals 3. So x equals 3 should give us a value of the rectangle that's greater than the value of the triangle. Okay, so if we do that, then we'll get this side length. 2 times 3 is 6 times by 3, and that will give a value of 9. So if we divide that by 2, we get 4.5. If we do the same for this one, we'll substitute in a value of x equals 3. So we do 3 minus 1, that will equal 2. And then in this case, we'll do 3 times 3 is 9 minus 2 is 7. That will give you a total of 14 when you find the area of the rectangle. And as we know, 14 is greater than 4.5. So excellent. We have found the right solution. So x, we know, is greater than 2. And we've tested that by putting in x equals 3 as a potential answer. Okay, that was a really tough question. There were a lot of bits in there that I think people would find very challenging. I would like to think that most people would realise how to get to this stage. Even if you left the inequality in, hopefully you'd be comfortable getting to this stage. I appreciate that then going on and using a graph to work out the inequalities and then deducing which inequality is then the best value of x takes quite a lot of really tough, really high level, complicated mathematical thinking. So really well done if you managed to get right the way through to the answer. So probably the hardest question that I've done on this channel so far. Please like and subscribe. I do a whole range of maths videos. So from I've got a number of them that questions you will find in the foundation paper. So if this was way beyond you, then don't worry about that. Check out one of the foundation videos. Equally, there are plenty more videos targeting higher questions. Potentially a little bit easier than this, right from the beginning of the paper ones, middle of the paper, and then some of the more challenging ones as well. So please subscribe to my channel and like the video. Hopefully you're feeling a little more confident with this style of question. And lastly, thank you very much for watching.